Hi again, and welcome to your lesson on mean. Today our goals dealing with mean are to calculate and interpret the mean of a data set, as well as describe the center of the data distribution, and center can be measured using mean or median. New vocab word, it is mean. It's the average of n numbers, is the sum of the numbers divided by n. This is something that's not new to you. When we get to using our graphing calculators, especially when we're looking at mean for our project that will be coming to at the end of this lesson, or excuse me, this unit, we're going to see that mean is represented by what we call x bar. This symbol here, x with a bar over top, is actually called x bar, and that's what it's going to look like when you start using your graphing calculators. So our first problem is also your first example. It's asking us to calculate the mean for the data set given. So we're going to do that. In order to find the mean, we're going to add up each of these data values and then divide by the total number of data points we have here. In this case, there are 8 of them. So we are adding 18 plus 25 plus 31 plus 32 plus 17 plus 36 plus 29 plus 12. Okay, and we're going to divide by the total number there, which is 8. When we add that numerator together, you actually get 200 divided by 8. And when we do that division, we get 25. So our mean here, or our x bar, is 25 for that set of data. This is the part that might be new to us this year. Part A asks what's going to happen if we add a score of 35 to the list of data. How is this mean going to change? Well, looking at the set of data, do we see very many scores around the 35 range? It looks like we have some in the teens, 1 in the 20s, or 2 in the 20s, and then 3 in the 30s, but only 1 is higher than 35. So overall, we could calculate this out and figure out what exactly will happen when we add 35 to this data set. But since 35 is larger than the mean that we just found, our mean is 25. Since 35 is larger than that average, we know that adding 35 will raise the mean. So we could actually write that, a score of 35 will raise the mean. Now, it might not be a drastic raise, but it will be a raise. How do we know that? Well, this is because 35 is greater than 25. Since 35 is greater than 25, the mean will increase. Okay. The last part down here says, okay, now we need to calculate the new mean. In order to save ourselves some time, we're going to try to be a little bit smart here. And instead of going back and adding 18 plus 25 plus 31 plus 32 plus 17 plus 36 plus 29 plus 12 all over again, we are just going to take that total that we got here, 200 divided by 8, and we're going to add the score of 35 to that. So we now have 200 plus 35 divided by 8. Oh, wait, but we added a score of 35. So this is actually going to be 8 plus 1 more score to that mean. So we get 235 divided by 9. And when we type that into our calculators, you get approximately 26.7. And were we right? Did that score of 35 raise the mean? Well, it sure did. My pen. There we go. That's our new mean. All right, let's move on to a different type of an example. Looking at example 2, I like this one a lot because a lot of students do ask, what do I have to get on the final in order to get a 90 in this class in A? So your first 3 quarter final percentages, so this is quarter 1, quarter 2, and quarter 3, are 92, 89, and 85%. You want to end the year with at least a 90% quarter average. What percent do you need to get for the fourth quarter? What's the lowest percent you need for the fourth quarter? So we need to figure out what that percent is. So let's just call it X for now. So we're going to let X equal the fourth quarter percent. So that's what we're going to let our variable be in order to solve for what that percent is going to be. So we know we're working with 92% plus 89% plus 85%. And when we add that fourth percent, and we're trying to find a mean here, because we're trying to end the year with at least 90%. So a total overall all year long. And we're dividing by, there's 4 quarters here. We want that average to be 90. So we set it equal to 90. And now we need to simplify and make sure that we're solving here for X. So if we add 92 plus 89 plus 85, we get 266. Plus X divided by 4, which equals 90. So now we have X in the numerator, and we're adding 266 to it and then dividing by 4. This is just, we need to simplify this a little bit. So I'm trying to get rid of that denominator of 4. In order to do that, I'm going to multiply by the reciprocal, multiply by both sides by 4. This makes those two 4s divide out. And so I can simplify. I have 266 plus X equals 90 times 4, which is 360. And now I'm going to subtract. All I need to do now is solve for X, and I don't have a denominator, so it's subtracting 266 from both sides. And I get that X equals 94. So what that means is that this is a percent. In fourth quarter, you need to get at least a 94% in order to end the year with a 90 or an A. So this is a totally new way for thinking about mean and how do I solve for some value in the data set, in this case X, if I want the mean to be a certain number. All right, we're going to try another example like this. For this one, this is another different kind of a problem. We know that there are 20 people in class, and the mean number of days until they can get their permit is 52 days. So what that means is with our whole class, we'll say it's our algebra class, and you guys are waiting to get your permit. You have to, on average, each one of you has to wait 52 days. So a couple of months you got to wait. A new student's going to come in and join the class, and their birthday is tomorrow. Oh my goodness. That's only 1 day away. So they're closer than 52 days away from getting their permit. How does this affect your mean? Well, if they're closer than 52 days away, we know that the new student should lower the mean because 1 day is less than 52 days. So the new student will lower the mean because 1 is less than 52 days. They have a shorter wait. And we can actually prove this by showing that, okay, we have 20 people. It doesn't matter what any one of those people's number of days they have to wait to get their permit is, basically how far away any of those birthdays are, because for each one of those, the average is 52. So in that case, we're just going to multiply all 20 of those people by 52, which is that mean. And then we're going to add in our new student 1 day away. And then we had 20 students in class. Now we added one. So we now have a total of 21 kiddos. When we multiply 20 times 52, I get 1,040. And we're going to add 1 and then divide by 21 to find our new mean. So this is 1,041 divided by 21, which is 49.6 days. That's our new mean. Okay, that's quite a bit lower than 52 days to wait for their permit. So you can see that if you throw in a kid with a birthday that's a lot closer than 52 days away, it's going to change that mean. All right, we're actually going to skip example 4 and move on to example 5. Example 5, we are looking to create a list of 10 numbers that meet the following requirements. So we have to have a mean of 32, a median of 22, and no mode. Your answers will vary here, meaning there's a lot of different answers you can have. I'm going to show you how I would do it, and you can go from there. So basically, a mode, that there's no mode. If we remember what mode means the number that comes up the most often. So if there's no mode, there's no repeats. No numbers are repeated. So we can't just list the same number over and over in order to get a mean of 32 and a median of 22. Median, again, means it's the number in the middle. But we're going to run into an issue because if we try to find the number in the middle, we have a whole list of 10 numbers. Well, if we cross one off here, and then here and here, and then here and here, here and here, we're left with 2 in the middle. So what I'm going to do is I'm going to force the middle number to be 22. When we take the average of 21 and 23, that's what you do if you're left with 2 numbers in the middle. And we can't have repeats, so I can't just write 22, 22. I'm going to write 21 and 23. Our median is 22. From here, I'm just going to write, let's say we'll go with 20, 19, 18, 17. I'm just throwing some numbers in right now. Well, if our mean is 30, this is the one that we need to use right now. That means for all 10 of these numbers, the mean is 32. So if we multiply 10 by 32, we get 320. This is what the sum of all of your numbers need to be. So far we have 17 through 23, and when I add all those numbers together, actually let's do 17 through 21. Just to keep it in halves. I get a sum of 118. That's my sum when I add all these numbers together. That means I need the sum on this right-hand side. In order to equal 320, I need this sum to be 202. All right, so I know I'm going to need some larger numbers here. So I'm just going to start with, and of course I know the answer, but I'm going to start with 49, 50, 51, and 52. Just because I know when I add 49, 50, 51, 52, and 23, I get 202. So now I've created a list of 10 numbers where the mean, the average is 32. The median, my middle number, is 22, and there is no mode. There's no repeats. All right, you should be all set now that you know a bit about mean. That's all I have for you for today. Thank you for watching. I'll see you soon.